Which numbers do we want to see do go over on the short way? 2, 2, 3, 4, 4. SL1, SL2, SL3, SL4, and I think 5 can be done on desmos. So starting with 1, is this positive, negative, 0, undefined? Positive, because going up and right. And then to calculate it, look at the points on the graph. You can either count from there or find other points. So this is going up 1, 2, 3, 4, 5, 6, 7, 8 over 3. So that should have been your slope. Questions on that one? Using desmos for that one wouldn't really help unless you put in that slope and saw if it was the same. Put in those points and that slope and saw if it was the same. 2, you don't need desmos, but I'll show you how you can double check yourself. As a reminder, parallel, they have to have the same slope. They're clearly not the same, so not parallel. Perpendicular, they have to be negative reciprocals, so same numbers but flipped. One's positive, one's negative. That would make it perpendicular. Neither would be some other case. They're either completely not perpendicular, completely not parallel, completely different, something along those lines. If you wanted to see that in desmos, they also have to cross and make that perfect T, so when they cross, they do make that T. So you could also say that they're perpendicular. They're 3, you could solve by hand, but you could also put in desmos to see how many solutions or the type of solution it has. So when I put in this equation, I get a line, a single line, so that means it has one solution at x equals 1. If you put in both sides and nothing appeared, you have to put in both sides separately. If they are parallel or don't cross, then it's no solution. If they overlap, that'd be infinitely many. Questions on those 3 so far? Or remember that every time you see write an equation, you should be trying to use this in desmos so you get used to this. I promise you there will be at least 1 or 2 of these type of problems on the SOL, if not more. So write an equation that passes through this point that's perpendicular to this equation. So put in your y equals mx plus b. It'll put in m and b sliders. Choose all. It's moving because I pressed play on B. I put in the ordered pair and the line that was already given. So it has to be perpendicular to that and go through that point. If it's perpendicular to this, the slope has to be flipped, and it was already positive, so we have to make it negative. And then, wow, that was almost spot on. And then it has to go through that point. So when our y value is 1, it'll do that. So the equation for that, and I forgot to put this in there, would be y equals negative 4 over 3, x plus 1. Questions on that one? And then the last one was an inequality that you had to graph. If you're using desmos, you don't need to solve. If you weren't using desmos, you would need to solve. But it should have been a dashed line, y-intercept at -3, slope of 1, shaded below. Questions on that? If you weren't already using Desmos, I need you to get Desmos out on your computer. Today we're talking about quadratic regression, so you may remember linear regression or line of best fit. This is now curve of best fit. So I'm going to show you how to do this on the calculator and on Desmos. On the test, you'll have access to both. On the SOL, you'll only have Desmos, so you need to be able to do both. We'll start with the calculator first, and then the next one we'll do Desmos, and then we'll kind of go from there. What's nice is if you know how to use Desmos with line of best fit, it's not too much different. You just have to know how to type it in. Right? Same thing with the calculator. So in the calculator, we're going to reset it first. Second plus 712. We're going to go into stat, next to the arrows. Go into edit, hit 1 or hit enter. In L1, you're going to put in all of your x values, and L2, you're going to put in all your y values. And you can do that by typing them in and hitting the down arrow or hitting enter. The picture on this is from the line of best fit notes, that's why the numbers don't match, ignore this picture. The rest match. Right. From there, step 2, go into stat, scroll over to calculate. We're no longer doing linear regression, so we don't need 4. Now we need quadratic regression, which is 5. Make sure your x's are in L1, your y's are in L2. We do want to store it, same as before. So go down to store regression equation, hit alpha trace, and enter 3 times. And it should give you an A value, a B value, a C value. That should look somewhat familiar because it has to look like this format, what we've been dealing with factoring, with quadratics, all of those things. So the line where it says curve of best fit, we're going to use these numbers and write it in this format. Y equals, our A value is -1, so you can put -1 or just negative, X squared, either or, doesn't matter. We don't have a B value, so we're not going to have a BX term at all. And then our C value is 7, so plus 7. The prediction piece is the same as before. Because we have the equation stored, we're going to change our x value and then do it that way. So it's asking what is the y value when x is 3 and when x is 4. So I'm going to go in and type 3 from the same screen, the STO above on, x, enter. I'm going to go back and hit alpha trace. Wherever I stored it, I'm going to hit enter and enter again. And that's going to tell me my y value when x is 3. We're going to do the same thing with 4. So now type in 4, the STO, x, and enter. And then go back and hit alpha trace and enter twice. So when x is 4, y is negative 9. We will do the calculator steps again if you miss any of that or need help with any of that. But in general, do you have any questions? The next piece is showing the same thing in Desmos. So those of you who have Desmos open, I'm going to do that same thing in Desmos. So just like your line of best fit, you're going to go to the plus and add in a table. We're going to use the same table we just used before, so the x's and y's, you can go ahead and put those in. Whoa. Once you have your table in, instead of your y equals mx plus b, because that's for linear, we're going to use the quadratic equation, the y equals ax squared plus bx plus c, but it's going to look a little different. So that's on your next page if you need to see what it looks like, if you haven't already gone there. So whatever the table numbers are, you have x1 and y1, we're going to use that. I'm going to type in y1. Then you need the squiggly line, the tilde. So if you're on your computer, you can type it in. I think it's above shift. Or you can look in the keyboard and it's at the bottom here. And then you're going to type ax1 squared. So after you type 1, then you can make it squared. If you type in squared and then 1, it'll do weird things. So 1 and then squared. Make sure you come down. And then you can continue. Plus dx1. And then plus. Just like the line of best fit on Desmos, it will give you all the values. If you want to rewrite it so it's all together in the next line, you're more than welcome to do that using the A, B, and C values. So that's the nice part about this is the steps are really the same. It's just which ones we type in or choose are a little different. Virginia. And maybe one of your points, but this is the same. It's just this is what the 0. That's what it is. It's the same. So sometimes it'll do that. Regina's instead of 0, it was like read it off. 1.218 times 10 to the power of 9. So that just means there's so many zeros in front of those digits is basically 0. Is 0. So if you get something like that, it's still 0. Right? Questions about Desmos or calculator in general? We are going to do more. In your notes, the biggest thing you need to know is the difference between the two. Sometimes your problems will say line of best fit, and that's linear. Sometimes it'll say curve of best fit, and that's quadratic. Sometimes it will say curve, and it can be either. So you have to look at the points and look at the graph and see which one it is. You have to know these two equations in order to successfully do your line or curve of best fit. If you're not sure, so let's say you're given a set of points and you're not sure, is this quadratic or linear, you could start to plot them. I'm pretty sure one is linear, but we'll plot it first. So start plotting these points on your graph. So on the graph, we can clearly see this is going to be a line. It's going to be linear. But in your table, you could also look at your x values keep going up and your y values keep going up. It's not going up and coming back down because that's what a quadratic would do. Plot the points for the second one. So is this one linear, quadratic? Quadratic. It makes that U shape. So then to find that equation, we can either use Desmos or the calculator to find it. I'm going to go back and do the calculator steps, just in case you missed that. If you want to do it in Desmos, feel free to do that. The next one I'll do in Desmos. So I'm going to go back into Stat, go back into Edit, and I'm going to clear these out. So go up to the top, hit Clear, and scroll back down. don't hit delete, and put in those points. Once you have all your points in, whether you're using Desmos or the calculator, if in the calculator, go back to stat, scroll over to calculate. We're just finding the equation, so we don't need to store this, but 5, or scroll down to 5, and calculate. Now, if you get a bunch of decimals, the problem should say what to round to. You could write all of them for me, but it should say what to round to as well. So let's say we just want to round to 2 decimal places. So we have y equals 0.43x squared. Plus 0.06x minus 2.03. Whether using Desmos or using the calculator, did we all get the same thing? No. Does not feel like I put in -2, so +2. I did do that. That's why I said that. Let's see if that changes things. That's what that should have been. I know. Okay, so that becomes just x squared plus 2x minus 1. That looks fun. Oh, and I should be able to. Number 3, if I'm looking at the table, I see my x's are going up and my y values start to go up, but then they go back down, so that would tell me it's going to be quadratic. So I'm going to do this one in Desmos after I plot these points. Right, it does make that U shape. It is quadratic, and we can find that equation. I just used the same table I already had up here and changed the values, which you are welcome to do. If you make a new table, remember that every time you make a new table, the values change. So when you type in your equation, instead of y1, x1, you'd be putting in x2, y2. Or you can just keep re-changing the table. Either or, doesn't matter. So the equation for this one should be y equals negative x squared plus 6x minus 10. Do we have any questions on how to find the curve of best fit or the quadratic regression in Desmos or in the calculator? We were going to do some word problems. Yeah. So for the next couple examples, the one that's talking about years. Anytime it's talking about years, years is a linear thing. 1 year after the next it happens. So that's always going to be a line of best fit. But the one after that, the coin is thrown off the top of the Statue of Liberty. So you have to kind of think of what's happening. If I'm standing on the top of the Statue of Liberty, I wouldn't be because I'm afraid of heights. But anyway, if I was up there and I tossed a coin off, it's kind of going to go up and come back down because of gravity. So it's going to make that parabola upside down. But you have to think about what shape that would make, and that will tell you it's going to make the quadratic. So you have to be able to tell the difference between a linear and a quadratic word problem, line or curve of best fit. Then we can find the equation. Do we want to use Desmos or the calculator? You guys choose Desmos, okay. So in Desmos, I'm going to change all these values. This table also, like, it kind of shows that, but in this one, you're going up and then it starts to come back down. That's also how you can tell that's quadratic. So your equation for this one is going to be negative 16x squared plus 78x plus 305. But now in this one, it doesn't just ask about the equation, it also asks what is the height of the coin after 7 seconds. So this works the same. Our height, we're looking for height, which would be like our y, after 7 seconds, which is our x values. So if you're using Desmos, I can type in x equals 7. You may have to zoom out. And find where x is 7. and find where they intersect. So the height after 7 seconds would be 67 feet. Thank you. I was looking for the measurement. There are more word problems on the back. On the further back. Are there any others we want to see you go over? If there are, go ahead, Virginia. Right. Sometimes you'll have pictures, so that helps. This is clearly a U shape, so that's going to be a quadratic. So we can find our equation. Do we want to use the calculator or desmos? Okay. So in your desmos table, go ahead and change those values. 0, 1, 2, 3, 4, 5. Those are the same. Okay, cool. 2, 4.5, 6, 6.5, 6. So the equation for that one would be negative 0.5 x squared plus 3x plus 2. And if we're looking for the height of the frog after 6 seconds, 6 is our x value, height is our y value, so we can put in x equals 6 and see where those two overlap or cross. So at 2 feet. We skipped over this one, but number 5 on the back of this, when it's measuring distance, distance can't be quadratic. That's a linear thing. Take out your testnav packet. We're going to go through 1 through 21 so you have those correct answers and show how you would do those in Desmos. And then you'll have time to do the last. Regina, do you have any answers? Yes. Anyone else need another one? Yes, Regina.
Where do my phones go right now? Like I was using my phone. I found what
Like when you did it practice-wise. I'm gonna go back and do that later. Alright, you may have noticed the formula sheet. They will give you this. I don't know if it's been updated, but to my knowledge, this is the same one. For the most part, you won't really need this, but if you get a word problem that says something about perimeter or area, you have those formulas. Right. Almost all of these can be done in Desmos. So I'm going to show you how to do it in Desmos and then show you the answer. So number one, if you put everything in using all of the different operations, your answer should have been 35. So B. Questions on that one? 2. If you either change your variable to something else, A through E, or make the x's capital, either or, and then type in, it'll ask you to make it a slider. Do that, change it to some value, put in all of your answer choices, and there should be only one that matches as long as you put in everything correctly. So 5 over d to the 18, that was the correct answer. D. If you are like going through these and maybe forgetting some of these tricks, I would write a note to yourself. Use slider, type in capital X and Y, put in all the answer choices, see which one matches. That way when you go to do this, you kind of remember these things. Okay. This one, for number 3. You can put in the original. The quotient means we're dividing, so put it in all at once. Put in all of the answer choices. And then one of these is going to overlap. So this was the original. I'm going to go back and do this one at a time. This is the original. This one does not overlap that one, so that's not the answer. This one also does not overlap that one, so that is not the answer. That one doesn't overlap, but that one does. So 5x minus 6 would be your answer for that one. We did just talk about this last week. On if you wanted to do it by hand, you would factor the numerator, find the factors that cancel. Questions on 3. If you missed that, that was D. For 4, you can, all of these can be done by hand, of course. The trick on Desmos for this is you could start putting these in and see which ones overlap or not necessarily overlap. Go through the x-axis. So here's your original. If you put in these two, they won't really do anything for you. But looking at just the numbers, you could see which of those could you divide each of these by. 9 wouldn't work, but 3 would, so 3 would be one of your answers. These two aren't simplified enough, or they aren't factored enough because I could take a 3 out of both of these and a 3 out of both of these. So you have to find the most simplest factors. But if I put in the following, only one of these can be the answer. Whichever one goes through the original at the x-axis, that would be your answer. So 3x plus 2. And then again, only one of these can be your answer, whichever one goes through your x-axis. So this one in blue, x minus 5 would be your answer. So 3x plus 2 and x minus 5 are all of the factors on that one. Questions on that one? Five and 6 and 7 can all be done in desmos if you're looking for which one matches. Great. So again, I changed the variables, but you could just as easily make them capital letters instead. It'll add in sliders, change them to positive values, because the negatives might throw it off, and then see which one matches. In 5, you'll get 2 that match. One will not be as simplified as the other. So these two, something's wrong with that one, but that one should have been the answer. I didn't type in something correctly. X is 4. I don't know why I put 4. There we go. I don't know. There we go. Okay. So 2 of them are going to match. But if you look at the inside, one of them can be factored more. Yes. Say that one more time. You can grab another one of those. It might just be on the back, but grab another one just in case. 20, if I'm thinking about the factors of 20, it has 10 and 2, 5 and 4, more factors than just 1 in itself. So that is not the most simplified one. This would be the most simplified because the only factors of 5 are 1 in itself. So D would be the answer for that one. Six, I think only one matches. So it's going to give you an answer. Again, there are 2, I misspoke, there are 2 that match, but look at which one is more simplified. 16 I can break down to 8 and 2, 4 and 4, and keep going. 2 I can only break down to 2 and 1, so that has to be the answer. C. Okay. And then 7 was a little weird because you had to put in the values to see which one would simplify to be that. So if you put this in, one of your answers has to simplify to be this depending on which one you put in. So if I put in 35, that doesn't do it. 245, that doesn't do it. 875, that one matches. So the 875 is your answer. C. Yes. Okay. The Q group, if you go into functions and go all the way down and choose this one, you'll be able to put the 3 in. Sophia, did that go through or not yet? try a different bathroom. Okay. Questions on the radicals 5 through 6 so far? Eight is, you could put that in desmos, but that wouldn't really help you if you don't know what it's supposed to equal anyway. I will go back and do this one in desmos. I don't think I have it. But if you take the things on the outside and multiply them together, and take the things on the inside and multiply them together, you should get 8 and then 6. If I were to put in both of those things, I should get the same answer. Sure. What was that? 2? And then times 2 times the square root of 3. And then we said the final answer was, and then now you could play the guessing game and start putting in random numbers and see which one equals. That could take some time. 9 is something you need to know. So if you get 1 equals 2, which is your answer? No solution. 10 we were just talking about last class or the class before that. Solutions to this. This is an easy desmos question. Type it in. Look at where it crosses the x-axis. Find the points that match. If you're not sure about the decimals or fractions, because it gives you fractions, put in one of the fractions or decimals and convert it and see if you get the same thing. And if you do, that is your answer. So C was your answer for that one.
So 0, what would mean is where it crosses the x-axis?
Yes. The zeros is another word for solutions, x-intercepts, yes. All right. Questions so far? Moving on. All right. All of your equations and inequalities can be done on desmos. You can do it by hand, but you can also do it on desmos. If you put that in, you just have to know how to read it. So this is a dashed line, so it's going to be greater than or less than. It's to the right, so it has to be greater than. So x is greater than, and then look at where it crosses the x-axis. X is greater than -9 would be the answer you would type in the box. Okay, questions on that one? Was another inequality, and it asks you to select array and drag and put the endpoint on it. So this will help you see the direction. It has to be a less than or greater than because it's a dashed line. It's everything to the left, so that has to be less than. So that would be the open circle pointing to the left, and you would put that at -4. So that would be like a drag and drop. You would choose the arrow and you would put it at -4 and it would make it an arrow as you did that. Questions on that one? Okay. 13. I don't know if I gave you this equation right. I'll make this up. So you would have to look at the numbers given and make up an equation, which would end up being this one. 7.5x plus 12.5y is greater than or equal to, because he wants to earn at least. So he could earn more, but he needs to earn at least 300. And then this will be the graph that goes along with it. The one that matches this is C. So you could look at where does this cross the x and y axis to kind of help you with that. Questions on that one? 14 was a systems problem, but it wanted you to pick where they would overlap. And that would be this area right here, which was the second section. So you would, on the SQL, click section 2, and then it would shade it for you. I don't remember what 15 was. Oh. So 15, you had to figure out the symbols. So you could put in different ones and see what they are, or if you know what they are, put it in and see if it matches. I was trying to figure out what this was. So the first one has to be a because of the slope and the y-intercept, if you compare it to what's on the graph, it has to be a solid line. So it has to be one of these two. And then it's shaded above, so it has to be this one. So greater than or equal to was the symbol for the first one. The second one had to be a dashed line. So one of these two. And then, because it's written backwards, you have to play with it a little bit. But this should be the one greater than, and it should overlap here. If you did it the other way, it wouldn't overlap in the same place. But you could test that out on Desmos and see does it match or not. Questions on that one? Goes back to our transformations. If you want to see it graphed, you can use Desmos, but if you know what the definitions are, you don't need them. Don't need it. Shifted is your y-intercept. From the original, the y-intercept is now at -1. So this one's your original, this one's the new one. Your y-intercept is now at -1. So that would be shifted down. And you would choose that from the drop down. And then the other one should be steeper or less steep. So if this is the original, this one is way steeper than this one. The 6 is greater than 1. So steeper was your answer for that one. Again, if you know what you're looking for, you don't need to use Desmos. But slope, you're looking for the steepness, so that's going to be multiplied or divided. And the slope changed to 1/2. Was 1, now it's 1/2. So 1/2 should have been your answer for that one. And then the y-intercept changed. It was at 0, now it's at 2. So that's always an addition or subtraction problem. So that would be more than, 2 more than. 18 is really a plot point, so you don't really need desmos for that, but to help you see it, you could use it. If it's been shifted up 2, your y-intercept is now going to be at 2, which desmos could help you see that. And then if the steepness is, or if it's now 3 times as steep, that's going to be your slope. So that would show you that. So you could use that line to plot points. But make sure you don't plot too many, because I don't know if it takes off for that. And then once you plot 2 points, a line would be created for you on it. So any 2 points on that line. Questions so far? Okay. 19, you are looking for the range, and you're given the domain. So you can put this in to look at what it looks like. And your range would have to start at 2 and keep going to infinity. I'm sorry, 3. And keep going. I was looking at the x value. So if it gives something like that, you can easily graph it. So B was your answer for that one. And then the next 2 can be done on desmos instead of you trying to solve it. If you're looking for the number of intercepts, not all of them are open. And it wants exactly 1, 0. It can only cross or touch the x-axis once. So the blue one doesn't touch it at all. The black one touches it twice. These both touch it once, so those would be your answers. 9, and then parentheses x minus 8, and then x squared minus 8x minus plus 16. Plus 16. '21 is similar, except it only wants the ones that has an x-intercept of 3. So the ones at 3 are green and red, nothing else. So then those 2 would have x-intercepts of 3. Any questions about desmos? Any desmos tricks that you need me to go back to? Right. I want you to finish the testnav packet, so 22 through 28. Try to use desmos on as many as possible. Let me know what questions you have. You guys can work together. Once you finish that, you can work on Khan Academy, but try to finish that first. Yes, yes.